Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem. The ammeter in figure P28.53 reads 3 ampere. Find I1, I2, and E. Okay, let's see here. This ammeter shows 3 ampere to the right, and look at this. The current goes to this junction here. Let's name this junction as A. And then let's apply the junction rule at A. Apply the Kirchhoff junction rule at A. And the junction rule said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And what is the current that goes in? This 3 ampere and this I1, right? It goes into A. So I will have I1 and then plus 3. Good. And then the current that goes out is only I2 here. So I will have this will equal to I2. Or I can isolate I1 here. So I will have I1 and that will equal to I2 minus 3. Good. Now we have 2 loops in this circuit here. Okay, for I1 it goes down, so I just follow that. So my loop also goes down, then goes to the left like this. And let's name this loop here as loop 1. And I2 also goes down, so I will have loop 2 also goes like this. So this one is loop 2. However, we need to put the sign in the resistor. For the battery, the long polarity here is the positive one and the short one is the negative one. This is also like that. The long one will be positive and the short one will be negative. But for the resistor, let's see here, I1 is goes there. So in this resistor, the current goes there, right? So here I use this convention where the current comes from is the positive side and where the current goes to is the negative side. Good. And here I will have 3 ampere goes to the right. So the current that passed through this resistor looks like that. So I will have the positive one here and the negative one here. Good. I2 is like this. So I will have this current goes to the left. So the positive one is here and the negative one is here. Why we need this? Because we need to apply the loop rule and the sign is important for the voltage. Okay, let's apply loop rule at loop 1. Good. How to apply loop rule at loop 1? Let's start from this 9-volt battery. Here the loop goes clockwise and the loop enter from the negative terminal. So I will have negative sign and then we have the voltage. What is the voltage? 9 volts. So I will have minus 9. Good. And then let's move on to this 3 ohm resistor and the loop entering from the positive side. So I will have plus sign. And remember, we need voltage, right? Because the loop rule is sum of the voltage is equal to 0. But then voltage is current multiplied by resistance. What is the current? I1. And the resistance? 3 ohm. So I will have 3 I1. Good. Now let's do one more component. It goes here. And here the loop entering from the negative terminal. So I will have minus sign. Okay. And then I will have 2 ohm. And multiplied by the current that passed through this 2 ohm resistor, which is 3 ampere. So I will have 2 multiplied by 3. Good. And then all of that will equal to 0, right? Because the loop will go back into this battery and we already calculate that. So we'll have all of that is equal to 0. Good. What can we do now? I will have minus 9 plus 3 I1 here, and then I will have minus 6 and will equal to 0. Okay, so I'll have 3 I1 minus 15 and that will equal to 0, or 3I1 is 15, and so I will have I1 here is 5 ampere. Good. We have the value of I1. However, from here we can get the value of I2. I2 is I1 plus 3, right? So I will have 5 plus 3. And so I will have I2 here is equal to 8 ampere. So we get the value of I1, which is this one here. And we get also the value of I2, which is this one here. Okay? And we still need to find out E here. And how to do that? We apply one more loop rule at loop 2. Apply loop rule at loop 2. Okay. And loop rule said that the sum of the voltage will equal to 0. Good. Let's start from the battery here, and the loop entering from the negative terminal. So I'll have minus here, and the value will be E here. Good. And then we will have to move on to this 1 ohm resistor, and the loop entering from the positive side, and I will have positive sign. And then I will have 1 multiplied by the current, and the current that passed through this 1 ohm resistor is I2, right? So I'll have 1 multiplied by I2. And then I will have one more component here. So we will have this entering from the positive terminal. So I will have plus, and then we will have 2 ohm, then multiplied by, here I will have 3 ampere. So I'll have 3 here, and all of that will equal to 0. Okay, now, but then we have I2 here is 8 amperes. Let's plug that in. So I have minus E plus 1 times 8 is 8. And then plus 2 multiplied by 3 is 6. And all of that will equal to 0. Then I will have minus E plus 14 is equal to 0. Good. And so we will have our E here is equal to 14. And the unit here will be in volt. Good. And I think that's all for this problem. We have found I1, and we have found I2, and also we have found E, which is the question asked by the problem. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.